Okay, so let's do this. We started the antiderivative. This is the part 2 of the same section. Uh, let's do the antiderivative of the trig functions. We know that the derivative of sine x is cosine x, and you just have to work in the reverse because the antiderivatives are inverse functions of derivatives. So when you take the antiderivative of cosine x, you get sine x plus c. More generally, you have when you have the derivative of sine of ax, you get a cosine ax. So when you try to find the antiderivative of cosine ax, what will you get? So when you work in reverse, so when you go this way, okay, so when you have to go the opposite way, you have to take the antiderivative of here and you're trying to get to here. When you do that, that means this is equal to sine ax, and when you divide both sides by a, you get 1 over a sine ax plus c, the entire derivative of cosine ax. So that means the entire derivative of sine ax, and then divide by this number, the coefficient of x. And of course, don't forget about our c here. So these are all the general antiderivatives involving the trig functions. The trig function, the antiderivative of cosine ax is 1 over a sine ax plus c, as we have seen, and sine ax antiderivative is negative 1 over a cosine ax. Antiderivative of secant square ax is 1 over a tan ax, and so on. So all these you have to memorize this. If you don't, you can always go back to your derivative rules and then work in reverse. Let's take an example. Let's see here. This says you have to find the antiderivative of secant square 8x minus 6x 6 cosine of x over 3. So let's do that. We know the rule. The secant square x is the derivative of tangent x. So here for secant square 8x, we have tangent 8x, and whatever is the coefficient of x, we do that. So 1 over 8 tangent 8x minus 6, entire derivative of cosine ax is sine ax, so x over 3. Okay, now, and then divide by, in this case our a is 1 over 3, so 1 over 3 plus c. So this gives you 1 over 8 tangent 8x minus 18 sine x over 3 plus c. So that's our entire derivative of this function given. Let's take another example. We have entire derivative of 12 cosecant 4 theta cotangent 4 theta d theta. We have to find the entire derivative of this, entire derivative of, so you have to think back again, what is the derivative, what function is there that has this derivative as cosecant theta cotangent theta, or you can go back to your these rules. So cosecant theta cotangent theta, so cosecant ax cotangent ax is negative 1 over a cosecant ax plus c. So let's solve this. We have here as, so this will be 12 is the constant multiple, so this stays cosecant ax cotangent ax. So cosecant 4 theta cotangent 4 theta, you have cosecant 4 theta, and this you divide by the coefficient of theta, so 4. This comes, and plus c of course, and 4 goes into 12 3 times, so you get 3 cosecant 4 theta plus c. That's your answer. Now the particular antiderivative, like when you have to find the antiderivative at some value. When the value of an antiderivative is given, then that would be easier than if we can find the c, of course, because c, till now we are writing that constant as c itself. So we have to find the antiderivative of this that satisfy that antiderivative at 1 equal 5. So first find the antiderivative of that. So let's solve that. So antiderivative of this function will be, this is the constant multiple, it stays x cube. So the power rule says add 1 to the exponent, so this becomes 4, divide by the new exponent, minus 2, this is x to negative 2, so negative 2, add 1 to the exponent, divide by the new exponent, which will be negative 1, and plus c. And this whole thing is given as 5 at 1. So we'll do that. So this comes out to be 2x to 4. This negative divided by negative becomes positive. This is 2. This gives you x to negative 1 plus c. Now antiderivative at 1 is given, so your x is now 1. Plug this 1 in this, so you get 2 times 1 to 4 plus 2 times 1 to negative 1 plus c, and this is given as 5. When you simplify that, you get 2 plus 2 plus c equals 5, so c will be equal to 1. And now your antiderivative will be, you write that as the antiderivative, the uppercase f of x will be 2x to 4th plus 2x to negative 1 plus 1. So that's our antiderivative of that. So moving on, like this tells you how to solve when the antiderivative at some particular value is given. So you know already the relation between the position and the velocity and the acceleration, right? So the velocity is the derivative of the position, and acceleration is the derivative of the velocity. So the antiderivative of the acceleration will give you the velocity, and the antiderivative of the velocity will give you the position. So let's take an example and let's see how we can use this knowledge here. Let's say a ball is thrown into the air from an initial height of 80 feet. Okay, this is the initial height with initial velocity of 20 feet per second. Initial height when t is 0. Initial velocity is given, and near the surface of the earth, acceleration. So note these things down. Initial position is given, initial velocity is given, acceleration due to gravity is given. You have to find the position of the ball as a function of time. Okay, and first you have to find the position as the function of time, right? You have to write the function as a function of time, and after that you have to find the height of the ball after 2 seconds. So how do we solve it? Note those things down, that acceleration is negative 32 feet per second. Now when you take the antiderivative of acceleration, you should get the velocity. So you say velocity is antiderivative of the acceleration. Antiderivative of a constant is this times this, because we are doing the antiderivative with respect to time. So negative 32t plus c. Now initial velocity is 20, that's given. Initial velocity is 20, that means at t equals 0, your velocity is 20. When you plug this value in here for t equals 0, and this velocity is 20, so you get c equal 20. Now the position, let's say this, I'm denoting it as P. So P equals the entire derivative of the velocity. You already have the velocity equation, negative 32 t plus 20. So plug that value of c here, and you take the entire derivative of this. You get negative 32 t squared over 2 plus ct plus d. Plug in the value of c, which is 20, and you cancel this here, so negative 16t squared plus 20t plus d. Now this is the position. Again, initial position is given as 80 feet when t is 0. When you plug that in here, you get the position equation as negative 16t squared plus 20t plus 80. So we started with the acceleration, antiderivative of that, and use the fact that initial velocity is 20, find the value of the constant c here, and the same thing with the velocity. You take the antiderivative of the velocity to get the position and plug in the values, and you get your position equation as this. Now the second part of the question is you have to find the position when t is 2. Plug that value of 2 here, and you get 66 feet. I'm not doing the calculation, like I'm not showing the exact calculation what I'm doing, but when you use the calculator, I can do it